Today, we're going to be looking at quadratic functions. We're going to look at these from an algebraic, numerical, graphical, and verbal perspective, extracting information and looking at the modeled functions. We're going to continue with the same example from our linear function video. We've been examining average monthly high temperatures in one southern US city during the year 2020. So you can see in our chart, we've replaced January with 1, February with 2, and then entered these into the X values and used the temperatures into the Y values. If you already have part of this data into your calculator, you can continue. If not, we'll go ahead and grab our calculators and enter all of the data now. To get to this area of the calculator, if you're starting from the beginning, you're going to press Stat, option 1 for edit. Under L1, we have our months, 1 through 12, and under L2, we have our temperatures. We'll write some notes here, just so that if you want to go back and review this, you know how to enter it on your calculator. But again, we press Stat, Edit, and enter our X values into L1 and our Y values into L2. In order to continue with your calculator, you will want to turn on this scatter plot. To turn on the scatter plot, you press second, Y equals, select option number 1, and you'll want to make sure that the word on is highlighted. If you have off highlighted looking something like this, arrow to the left, press enter, and that will change so that the word on is highlighted. So to turn on the scatter plot, again, we pressed second, Y equals, which took us into the stat plot menu, and selected on. If you go to your graphing calculator now and press graph, yours may or may not look like my picture. So let's take a look at how we can kind of get on the same page here. I'm going to clear out some of the information from my calculator and then back up so that you can look at things. We can look at everything kind of together. So typically your graphing calculator starts off with a 10 by 10 viewing window. If you press zoom and option 6, this is what we call a standard viewing window. And we're not going to be able to see any of our data here, mainly because our temperatures are much higher than 10. We're also going to be limited because this stops at 10, which would mean that it stops at October rather than going on through December. So we want to fix this viewing window so that we can see our temperatures. So we would press zoom and option 9, zoom 9. And this would give us a U-shaped curve. We would be able to see our temperatures going up and down. So again, back to my calculator, back to my notes here. I turned on the scatter plot and then I pressed zoom and number 9 so that my data is centered. There's a couple of snapshots in here if you want to refer back to these. The next thing that we want to do in step 3 is we want to find a regression equation, or we want to find a line that can go through as many of these points as possible. So on your calculator, you'll press Stat, arrow to the right, Calc, down to option number 5, Quadratic Regression. This shows us that the X values are being pulled from list 1, the Y values are being pulled from list 2, and then we're going to specify that we want this regression equation stored into the Y equals. So in order to do this, we press variables, arrow over to Y variables, 1 and 1, That will key in a Y1 here, arrow down to calculate, and hit enter. So this is the regression line. Notice it's in quadratic form, ax squared plus bx plus c, and then it gives you the values that would go in for the a, the b, and the c respectively. Again, we snapshotted this in. And so if we wanted to write this line, then again, we would just kind of fill in these A's, B's, and C's. So in our notes, we could say y equals, we can round a couple of decimal places here, negative 1.34 x squared plus 18.31 x plus 23.14. So we can write it with an equation like that. We can also write it in function notation. We can replace the y with an f of x. And then everything on the right would stay the same. Let's go back to our calculator here. So now if we press graph, you'll see that we have a line that goes through kind of in between or in the middle. It's called a best fit line. We can see that being drawn onto our screen. And if you scroll down, you can see that I have this snapshotted in as well. So question number 4 says, does this model better fit the data? So we had talked about in our first video how we had a linear function, and the linear function went up and it kept on going. So when we reached like the highest or warmest part of the year in June or July, we would have expected the curve to go back down. The linear function didn't do that. So the quadratic does for us what the linear function doesn't do, in that the quadratic goes up, but then once it gets to the peak, it does come back down. So does this model better fit our data? This answer is yes. Goes up and it goes back down. So we're working a little bit more with function notation. Question number 5 asks us, what is f of 5 and what does this mean? Well, f of 5 means that what is the temperature when we plug in a 5 for our month? So whatever you see in parentheses here, this is the X value that you're substituting. So if we did this by hand, you know, we could go back to the function that we wrote above, the negative 1.34 x squared plus 18.31 x plus 23.14. Maybe we want to copy it out of this window. But basically what happens is we're just substituting a 5 in for each of our variables. So negative 1.34, plug in the 5, square it, add 18.31. But that 18.31 would be multiplied by 5 first. We're doing order of operations. And then at the very end, we would add 23.14. So when you see f of 5, again, what it means is to plug in the 5 anywhere that you see an x, perform order of operations, and see what it comes out to. We can do this on our calculator. If you press graph, you can go into second calc, option number 1 for value. This will let you type in any value you want for x. So here we're putting in a 5 and we hit enter. And this will position the cursor to that particular ordered pair. So if you plug in a 5, you should get 81.22 out. So f of 5 is approximately 81.22. This is approximate too because we rounded a little bit. So what does that mean? Well, it means in the 5th month, so the 5th month would be May, we would predict the average monthly high temperature to be equal to approximately 81.22 degrees. In question number 6, using the predicted model, what is f of 7.5 and what does that mean? Well, again, you can go back to your calculator. You can press second calc, option 1 for value, type in 7.5, hit enter, and this gives us 85.19. Let's keep a couple of decimal points to be consistent here, 85.19. So what does this mean? Well, 7 would correspond to July, so if it's 7.5, then we're talking maybe somewhere halfway through July. So in mid-July, the average high temperature is approximately 85.19 degrees. Question 7 comes along and it actually asks us something in the reverse direction. We still have the same set of data, we still have the same predicted model, but question number 7 is asking us, when is the temperature most likely to be 65? So rather than plugging in 65, we're trying to take the 65 and work backwards to find out what month that is. So the easiest way to do this using our calculator is to go into the y equals button, go down to y2 and type in a 65, and then hit graph. So let's write this down. And so if we look at our graph, there's 2 places here where the temperature is approximately 65. We can find each of these points by going second calc, number 5 for intersect, go to the left, first curve, notice we're on the blue line, second curve, we're on the red line, guess. We can arrow over, or our calculator is also smart enough to kind of figure things out without us. But this shows us that our intersection is at 2.965. So we could write f of 2.9 is approximately 65. So this would mean toward the end of February, we would expect the average high monthly temperature to be 65 degrees. We go back to our graph. There's another point or ordered pair where this occurs, where y is equal to 65. So if we want to find this point, we're going to say second calc, go down to option number 5 for intersect, go over to the right, hit enter, changes to the red line, hit enter. When it says guess, hit enter again. And so here we have when X is equal to 10.78, Y is equal to 65. So we could write in function notation, F of 10.8 approximately is equal to 65 as well. And so this means at the end of the 10th month, or at the end of October, the average monthly high temperature is also 65. Okay, so we have just a couple of questions remaining here. Question 8 says, using the predictive model, what is the maximum predicted temperature? We go back here on our graph. The maximum occurs at the top or at the peak. This is also called the vertex on your quadratic. You may have solved the vertex using a formula maybe in another class. So sometimes they would use this vertex formula, which is X equals negative B over 2A. And so if you remember in our problem, we had those A, B, and C coefficients. You could plug those in by hand, and this would give you the X value. But we're going to use our graphing calculator today. So with our graphing calculator, we're going to press second calc, option number 4 for maximum. And we need to arrow our cursor so that it is left of the peak. If you notice at the bottom here, it says left bound. So that just means enter it anywhere left of the peak, hit enter. You'll see it kind of sets a boundary line. Then go to the right. Right bound, hit enter. This tells our calculator that the peak is somewhere in between these two boundary lines. When it says guess, you can arrow it to where you think the peak is. Again, the calculator's smart enough to figure it out. And so if you hit enter, it'll put your cursor on the exact peak or on the vertex, and it'll list its coordinates at the bottom here. So this 6.8 would be the same thing as if you plugged in these numbers here by hand. So using our calculator, we said second calc, maximum. We set the left and right boundaries. And pressed enter 3 times. 3 times being 1 after the left boundary, 1 after the right boundary, and 1 after the guess. And so our point here is 6.84. Maybe we'll just say 6.8 and 85.8. So that's the ordered pair. So let's look at the question though. The question says, what is the maximum predicted temperature? Well, if you recall, our X values were our months, our Y values were our temperature. So the max predicted temperature is approximately 85.8. And when would this occur? Well, this occurs toward the end of June. June because it's the 6th month, 0.8, meaning that it's at the end. Our last question here, what is F of 18 and does this make sense on our model? So going back to our calculator, if you want to calculate any corresponding value given an X, you can say second calc value, and this pops up the X equals and lets you type in any X value you want. So if I type in 18 and hit enter, you'll notice that I get an error message. And the reason I get the error message is because our model is really designed only to work between January and December. And so when we say F of 18, you know, December ends in 12. So 18 is really going on into the next year. it doesn't really make sense based on the amount of data points that we have right here. So this doesn't make sense. And so what would be a reasonable domain? And so domain means kind of like what X values actually make sense for this model. So as far as domain goes, it only makes sense for our months. So our domain should be for the months between January and December. And so we can kind of write this kind of verbally. Sometimes you'll see domain written in interval notation. And so if you see something like interval notation, then maybe they would say something like January starts with 1, and you would include the January, so you would put a bracket on that side, and it goes through December. And if you remember, we had some of these decimal values, so you could really technically go through December 31st. So maybe you would write something like 1 to 13, but you would put a parenthesis on it. And so this particular type of notation means that it would include the January that you start in, but when you use 13 in a parenthesis, this means that this number is not included. So it would not include the following January. In other words, this would be the values 1 all the way up to maybe like 12.99999, you know, the very end of December. And so this is more of a thought question so that you're looking at your data and making sure that you're making predictions based on what you can do. In other words, you don't want to predict something way out in the future that doesn't really make sense. You don't want to predict something in the past that doesn't really make sense. Okay, hopefully you guys enjoyed this on quadratic functions. Feel free to look back through the notes here or the video, and then we'll pick up on our next function next time.